Uh, Good morning. Welcome to today's grade 12 counting principle lesson. My name is Khadile Mampolo. Today's lesson is about counting principle, which is you are learning it for the first time in grade 12. In this topic, we are dealing with the permutations, combinations, arrangements. Without wasting time, let's just look into it. Suppose you are given the word parliament, where you will take the same letters as different. So in the coming slides, it means all the examples that were given is when we take same letters as different. Let's consider the word parliament. And how many ways how many 10-letter words can be formed out of the word parliament, or how many 10-letter words can be formed out of the word parliament if letters are repeated? So it will be 10 to the power 10, which will be 10 billion. It means 10 billion words can be formed. What does this mean? Because repetition here is allowed. It means when you choose the first letter of the new word, you choose out of 10 letters of the word parliament. Now, when you choose the second one, since you are repeating the letters, you are still choosing out of 10. So meaning that every time when you choose the letters of the new word, then you choose out of 10 because repetition is allowed. So, but we know that we can just say 10 to the power 10. Then that will be 10 billion. It means 10 billion words can be formed out of the word parliament. Now let's look at the word letters can be when repetition is not allowed. If you are still forming a 10-letter word using the word parliament, it means when you choose the first letter, you'll be choosing out of 10. Because repetition is not allowed. When you choose the second letter of the new word, you'll be choosing out of 9. Then it means now they are no longer 10, they are 9. For instance, if the first letter is T, it means we are not going to have T. So because repetition is not allowed, then you'll be choosing out of the 9 letters from P to N. So then when you choose the third one, choose out of 8, 7, and so on. So the answer will be 3,628,800 words that can be formed out of the word parliament if the letters are not repeated. But the shortcut, you can just use 10 factorial. If you are using a Casio, you say 10, you say shift, then you go to the key below the mode, which with exclamation mark, then it will be the shortcut of this. Then it will be 10 factorial equals 2, then you'll get the same answer. Now, here is just an explanation of what I just said. To say when repetition is permitted, then I explain what I just said now. Now, let's say now you are required to determine the number of, you are forming a 6 letters word, but you are still using 10 letters of this parliament. So it means you form 6-letter word out of the 10-letter word, which is the parliament, So let's see if letters are repeated. It means when you choose the first letter, you choose out of 10, second one out of 10, third one out of 10, fourth one out of 10, fifth one out of 10, 10 out of 10, because the sixth one out of 10. Because letters are repeated in this case, then it means million 6-letter words can be formed out of the word parliament. Or you can just say 10 to the power 6. Now, if you are forming 6 letters word out of the word parliament, it means when you choose the first one is 10, the second one is 9, the third one is 8, fourth one is 7, 6, 5. Then it means 151,200 words can be formed out of the the word parliament if you are forming 6 letters words. So the shortcut, you can just say 10 factorial because you are forming 6 letters words. You say 10 minus 6 factorial. So the answer will be the same. That's the shortcut if you don't want to say 10 times 9 times 8 times 7 times 6 times 5. These shortcuts, you need to know them because, for instance, if you have 13 letters words, obviously writing all this, it will be a problem. If I say you have a 13 letters words, you only form want to form 6 letters words, you'll just say 13 factorial over 13 minus 6 factorial. Then you get the answer. That's the shortcut. Here, you say 10 times 8 because letters are not repeated. Here's the explanation of what I've just said. Now, again, we're still treating same letters as different. Now, in how many ways can the word be formed if the word start with P? Now, if the word start with P, it means P will be fixed at the beginning. It means you'll be playing around with only 9 words. So 1, it means P is fixed at the beginning, then you play around with 9 letters. So then that will be 1 times 9 factorial. It means 362,880 words can be formed if all the words start with P. It means you'll be playing around with 9 letters, which is A up to T. The next one, in how many ways can the word be arranged if the word starts with P and ends with T? So meaning that P and T will be fixed. 1 times 1, then we'll play around with 8 letters. That's why you have 8 factorial. It means if you want to form a word where the word start with P and T, because P and T start and end with P. If P and T are fixed, it means you're playing around with 8 letters. So the total number of words, so the words that can you form out of the word parliament, if the word start with P and T, it will be 40,320. Here I explained what I just said, and then you'll know what to do. Then if the word start with P, we can only play around with 9 letters. If the word start with P and end with T, we can only play around with 8 letters. In how many ways can the word be rearranged to form 10-letter word if the word start with a vowel? Now, we say here is 4. It's not 4 factorial because the word is not starting with vowels. It's not with only 1 vowel, but how many choices do we have? We have 4 choices. Then we choose 1 vowel. After that, choose 1 vowel out of the possible 4, which is A, I, A, and E. Remember, we take same letters as different. So then it will be 4 times 9 factorial. It's not 4 times 6. No, it's 4 times 9 because we are not saying 4 vowels should be at the beginning. We say 1 vowel should be at the beginning. So if you choose 1 vowel out of the possible 4, you remain with 9. So the rest of the 3 vowels will be mixed with other letters, then you play around with them. They are 9. So 4 means you choose 1 vowel out of the possible 4. That is why it's not 4 factorial. So then we'll remain with 9. After that, then you play around with those letters. 9 letters. Now, let's look at this one. In how many ways can the word be rearranged to form 10-letter words if each word starts with all the vowels? Now, here we say 4 factorial. We have 4 vowels here. We have 4 factorial because meaning that the vowels must be at the beginning. But we say 4 factorial because these vowels can still be arranged differently. We say the vowels are at the beginning, but we didn't say the first vowel must be A or what. We just say the vowels are at the beginning. It means there are 4 vowels which can be arranged differently, but remember we treat same letters as different, then take the 2 A's as different. So now if the vowels are at the beginning, now it means term number, the letters number 5 up to 10, there will be consonants. Then how many consonants are there? There are 6, which is P, R, L, M, N, and T, which can still be arranged differently. So then it will be 6 factorial. He explained to say there are 4 vowels in the given word. 1 vowel will be chosen out of 4 possibilities. Then the rest, including the 3 vowels which were not chosen, will form the rest of the last 9 letters of the word. This means after a vowel out of 4 has been chosen to be the first letter of the word, will still be 9 remaining. So we choose out of 9 to form the other 9 letters. So the other one, if 4 vowels are at the beginning, the arrangement was not specified. They can still be arranged differently at the beginning. Hence, we have 4 factorial. Then we remain with 6 consonants, which can be arranged differently at the end from position 6. So from position 5 to 10, so there are 6, then we say 6 factorial. So here I illustrated this with something like a tree diagram to show that if the first letter is A, remember these 2 A's, we take them as different. It means the other 9, including the vowels, the 3 vowels, then can still be anywhere. So if the first one is I, we'll not have I here. We'll play around with 9 of them, excluding I. If the first one is the other A, because we treat them as different, we have A here, we have the 9, which you can play around with them. If the first one is E, you have the 9 without E, that will play around with them. That is why I say 4 factorial terms. I was just illustrating what I explained. It's in slide 8. And then slide 8 again, the one where we say in how many ways can the word be rearranged to form 10 letter words. If each word starts with all the vowels, it simply means that these are the vowels. These vowels can be arranged differently. Does not mean that this A can be at the beginning. We say 4 factorial because they can be arranged differently. So from letter number 5 to 10, there are consonants that can also be arranged differently. Hence, we have 4 factorial terms, 6 factorial. In how many ways can the word be arranged if the vowels are put in alternating position? Now, here, the vowels are put in alternating positions, but they are not necessarily at the beginning. It means now the vowels can put between any 2 letters, but they are together. But now they are, unlike the previous one, they are not at the beginning. They are anywhere. So we say 4 factorial times 6. Remember, if the vowels are together, we'll remain with 6 consonants. Those 6 consonants which are not grouped, now the vowels are grouped, though it means we are changing 7 things here. The 6 consonants which are not grouped, plus the group of vowels, so hence we have 7. So it means we'll be playing around with 7 things here, which is the 6 consonants which are not grouped, and the vowels which are grouped. So vowels can be anywhere, but they're together. In how many ways can the word be arranged if the word starts with a consonant? So here, the consonants, there are 6. But it's not 6 factorial because we're not saying the word start with the consonants, but we said the word start with a consonant. But we have the possible 6, the 6 possibilities. That's why we say 6, not 6 factorial, because we choose 1 consonant that will be at the beginning. It means the other consonants will be with the 9. Then you play around with them to form the new word out of, but where that vowel that you have chosen is at the beginning. Here I did explanation of the slides. In this case, vowels are in the alternating positions, but not necessarily at the beginning. So that is why then in one group of vowels which can be arranged differently, I'm explaining, remember here I'm explaining the 2. Here, the first one where is where 4 factorial times 7 factorial. Then we say that group of vowels which can be arranged differently, and 6 consonants plus 6 consonants which are not in alternating positions, hence we have 7. So it means in 6 consonants which are not grouped and group of vowels. Then you play around with 7 things here, which is the 6 consonants and the group of vowels. Hence, we have 7. The other one consonant out of 6 is fixed at the beginning. That is why it is 6, not 6 factorial, because we say one consonant must be at the beginning, and then but we choose out of what, 6. So that is why we have 6. We have 6 choices. That it can be P, it can be R, it can be L, it can be M, it can be N, it can be a T, but you choose one that will be at the beginning. That is why we have 6, not 6 factorial. I just illustrated this thing to say, you see that you'll play around with P, R, L, M, N, and T, then the group of vowels that will be together. We don't know whether they're in the middle, at the beginning. This can be between P, this group of vowels can be between P and T, they can be between P and R, they can be anywhere, but they're together. So that is why we say we'll play around with 7 things here, which is the 6 consonants and the group of vowels. Hence, we have 7 here. Now, I just illustrated this where we say they start with the consonant. If the consonant is N, for instance, so we'll say if it's N, it means that the N will be at the beginning, then we'll play around with 9 letters, including the consonant, the other consonants except N. If it's a P, you'll play around with N to form the new words, excluding P. Here is L. So, but if you see, these are the consonants that they can possibly be at the beginning, hence you have 6. But every time after you have chosen one consonant that can be at the beginning, then you'll play around with the 9 letters, including the consonants which are not at the beginning and the vowels. So we're still treating the same letters as different. In how many ways can the word be rearranged to form 10 letter words if the word starts with all the consonants? So now the consonants are at the beginning. That's why I have 6 factorial, because now there are 6, but we didn't say the first one must be P. That means those consonants can still be arranged differently. Then it means after the consonants are at the beginning, the consonants which can be arranged differently are at the beginning, where it means number 7, 8, 9, and 10 will be the vowels, which can still be arranged differently. Then you have 6 factorial times 4 factorial, which is 17,280. In how many ways can the word be arranged if consonants are put in alternating positions? Now, the consonants are put in alternating positions, but they are not necessarily at the beginning. It means you'll play around with 4 vowels and group of consonants. Hence, we have 5. So we have 6 consonants which can be arranged differently. Then because now here the consonants are not saying at the beginning, but they are next to each other, then it means you'll be playing around with 4 vowels plus the group of consonants which can be anywhere. Explanation here: the word starts with a group of 6 consonants which can be arranged. Which can be arranged. I forgot to put B here. Be arranged differently. That is why it is 6 factorial. Not just 6. Not like the one when we said the word start with a consonant. One here is not starting with not one consonant. It means all the consonants are at the beginning. So, but they can be arranged differently, and then from number 7 to number 10, there will be vowels, and these vowels can still be arranged differently. Then you have 6 factorial times 4 factorial, which is 17,280. The explanation of the one where we say the consonants are in alternating position. The consonants are now grouped, but they are not necessarily at the beginning. Then it is group of 6 consonants, which can be arranged differently, plus vowels, which are not alternating positions. then the answer is 5. And the answer is 5. It means you play around with group of consonants, which 4 vowels which are not grouped. Then hence we have 5 there. Illustrating of this one. So it means this ones we say they are at the beginning. They can be arranged differently. And then these ones are from number 7. They can still also be arranged differently. Here is that one where we say the consonants are at the beginning. So they can still be arranged differently. We're not talking about one consonant, but we are talking about all the consonants. These consonants can be arranged differently. These vowels can be arranged differently, but we know that the vowels will be on the right, the consonants will be on the left. But the one where we set the consonants are put in alternating position, it means these consonants are together, but we didn't specify whether they are at the beginning or what. It means here we are playing around with the 4 vowels and the 6 consonants, which can be arranged differently. So it means you play around with 5 things here, which is 4 vowels and the 6 consonants, which can be arranged differently and can be put anywhere. So we are playing around with 4 things: group of consonants and 4 vowels. Hence we have 5 there. But remember, we have 6 here because now even this consonants are moved as a group. They can be arranged differently. It does not mean that P must be at the beginning. It does not mean so. These consonants can still be arranged differently, being grouped as they are. Now let's look at now this one. Now in all the slides that the previous slides, we say treating the same letters as different. Now let's look in cases where you treat same letters as identical. Consider the following word: mathematician. In how many ways can this be arranged to form 13 letter words? Remember, mathematician has 13 letters. If we treating the same letters as different. If we treat same letters as different, you check letters. We are the number of letters that are repeating. Like here in the word mathematician, M is repeating. There are 2. That's why we have 2 here. You divide by the number of letters which are repeating. If they say treating same letters as identical, so M is repeating, hence 2 here. T is repeating, hence 2 here. I is repeating, hence 2 here, and then A is repeating 3 times, hence 3 factorial here. That is why when it is 2, you don't necessarily have to say factorial, because 2 factorial is just 2. There's no need to put factorial. Even 1 factorial is just 1, but 3 factorial is not 3. 3 factorial is 3 times 2, which is times 1, which is 6. So when it's 3, then you say 3 factorial. In how many ways can the word be arranged to form 13 letter word if words start with M? Here, words start with M. So it means M is fixed. So it means you play around with 12 letters, hence 12 factorial. But because M is fixed, so it means we'll be left with 1 M. Then M is no longer repeating. We'll have only 1 M that we play around with. So it means in this case T will repeat, hence 2 here. I will repeat, hence 2 here. 3 factorial because A will be repeating. I explain this or to say because M is repeating, T is repeating, I is repeating, A is repeating, hence we have 2 times 2 times 2 times 3 factorial. No, and then the other one, the next one, M is not repeating because we said the word start with M. It means the letters that we'll be playing with around with does not include. It will have only 1 M now because the M that is fixed is not changed. Still taking the same letters as identical. The word mathematician. Now, in how many ways can the word be arranged to form 13 letter word if the word start with A? If you start with A, it means M will repeat, Starting with A first, A will be fixed, then we'll play around with 12 letters. M will repeat, hence 2 here. T will repeat, hence 2 here. I will repeat, hence 2 here. But A, 1A is fixed, then it means we remain with 2 A's. Then only 2 A's will repeat, then we'll have 2 here. In how many ways can the word be rearranged to form 13-letter word if the words start with M and end with N? Still treating same letters as identical. So we say 11 factorial because A, you can just say 1 times 1 times 11 factorial because now M and N will be fixed. So it means we'll play around with 11 letters. So it means since M is fixed, 1 M is not repeating. So M is not repeating because we'll be remaining with 1 M. So here is only T will repeat, I will repeat, and A will also repeat. That's why I say 3 factorial. Then the answer will be the possible number of ways that can be formed if the words start with M and end with N, and then we're treating same letters as identical. Here is the explanation to say M is no longer repeating because now 1 is fixed, will remain with 1 M, then only let me say this here. The first one where starting with A, it means A will remain 2 A's. So A will repeat, M will repeat, T will repeat, I will repeat. The same with this one. Explain that M is no longer repeating because 1 M is fixed. Then we'll be playing around with 11 letters, and then in those 11 letters we'll have only 1 M. We're still talking about the same word mathematician, treating same letters as identical. Now, in how many ways can the word be arranged to form 13-letter word if words start with A and end with I? If you check here, A will be fixed, I will be fixed. Now, we'll play around with 11 letters, hence 11 factorial. So if start with A, it means we no longer have 3 A's that are repeating. We'll have only 2 A's that are repeating. We have 2 is for 2 A's that will be repeating, 2 T's will be repeating, and 2 M's. It means 2 A's, 2 M's, 2 T's. I is no longer repeating because one of the I's is fixed at the end. Here I can say in how many ways can the words be rearranged if the word starts with the same letter and ends with the same letter. Now in this case we didn't specify whether that same letter is M, whether that same letter is A, excuse me, whether that same letter is T, whether that same letter is I. So because we didn't specify, we must include all the possibilities. The first possibility is when that same letter is M. If that same letter is M, it means M is not repeating. So it means now only only T, I, and A will be repeating. Plus, here is when that same letter is a T. If that same letter is a T, it means M will repeat, I will repeat, A will repeat. Here is when that same letter is I, it means M will repeat, T will repeat, and then A will repeat. Now, if that same letter is A, it means M will repeat. Remember, if same letter is at the beginning and end, it means A will be left with only 1 A. Then A is no longer repeating, and this will repeat. Then M will repeat, T will repeat, I will repeat. Meaning in this case, because we didn't specify what that same letter is, then we write all the 4 possibilities. Then the answer will be 9,979,200 ways that can be formed if the words start with same letter and end with same letter. This is the explanation, as I said. Now, let's look at the arrangement. There are only 6 chairs for 13 learners to be seated in a different way. In how many ways can they be seated? In how many ways can they be seated? We'll just say 13 times 12 times 11 times 10 times 9 times 8, because we have only 6 chairs. This will be the shortcut as we did in the previous slide. In how many ways can they be seated if same learners sit at the end without changing? Now, unlike with weights, if we are on we put the 6 chairs on the stage, we say one learner sit at the end without changing. We didn't say the left end or the right end, so we write the 2 possibilities. But we know that one learner will be at one point. It means we'll be changing learners in the middle. So it means we'll be playing around with 6 chairs. But remember, we say one learner. So it means we'll be changing 12 learners. And then, but why do we have 2 possibilities? Because we didn't specify whether we say the left end or the right end. So this learner can be on the right end or the left end. Then the answer will be 190,080. I did explanation, as I said. Let's say we have letters A to H. Here we talk about groupings. In how many ways can the letters be arranged? It's 8. Remember, 8 factorial, because there are 8 letters. In how many ways can the letters be arranged if A and B are put in alternating positions? So it means A and B now, they go as a group. Then you have the group of A and B go together. There is one thing. Then 1 plus that's the 6 letters left. Then it will be 7 factorial. In how many ways can letters be arranged if A and B and C are put in alternating positions? Then we'll say A and B and C. Now we say factorial because they are 3. Because A and B and C, they can be arranged differently, but they are group. Then we'll be left with 5. Then it will be the group of these 3 letters, which is A, B, and C, plus the 5 left. Then it will be 6 factorial. So it means here we're changing 6 things here. 5 letters, which is D, E, F, G, and H, which are 5, plus the group of the group, which is A, B, and C. Then it will be 6. 5 plus 1 plus 1 group, which is 6 factorial. Then they can be arranged in 4,320 times. Here this explanation. Here's the explanation. In how many ways can the letters be arranged if A, B, C, and D are put in alternating positions? Now A, B, C, and D are in now a group. Then we'll be left with 4, which is the E, F, G, and H. Then we say 4 plus the group, which is made up of A, B, C, and D, because they're put together. Then it will be, now you are changing 5 things here, which is the group plus 4, which are not grouped. Now, how many ways can the letters be arranged if consonants are put in alternating positions? Now, we have 4 consonants, which can be arranged differently, but it's a group, 6 factorial. We have two vowels, which is A and E. So, but we know that for vowels, you don't say factorial, because 2 factorial is just 2. Then we have 2 groups, meaning now there can only 2 arrangements. It means a group of vowels can be on the left, the group at the beginning, and then the group of consonants can be at the beginning, the group of vowels can be at the end or the group of the vowels can be at the beginning, the group of consonants can be at the end. That is why we have only 2 possibilities. We can only arrange these 2 groups differently. Then this is the explanation. Same thing with the grouping here. there are 3 maths books, 4 history books, and 5 literature books should be arranged on the shelves. Be it in the library. How many ways can the books be arranged? We have 12 books in total. It will be 12 factorial. Then you will get the answer here is the possible number of arrangements. Then in how many ways can the books be arranged if math books are put in alternating positions? Then we say because math books now they are a group, then it will be 3 factorial, meaning that there are math books that can be arranged differently. Then we'll be left with 9. Then we'll be arranging 9 books that are not arranged, that are not grouped, plus 1 group of maths learners. Then they make it 10. Then it will be 3 factorial times 10 factorial. Then I explained here, as I said, there are 13 maths. Okay, it's still the same question. In how many ways can the books be arranged if history books are put in alternating positions? History books here, there are 4. It will be 4 factorial. Then we'll be left with 8. 3 plus 5, which is 8. Then it will be 8 plus 1 group of history books, which is 9 factorial. Then you get the answer. In how many ways can the books be arranged if the maths books are put in alternating positions and history books are also put in alternating positions? Now, we know that we have 3 maths books, 3 factorial. We have history books, which are also groups, 4 factorial. Now, we didn't say the literature books are grouped. Then it will be 5 literature books plus group of history books plus group of maths books. Then it will be 7 factorial. Then you get the answer. So meaning it will be 5 literature books that are not grouped plus the group of history books plus the group of maths books. Then hence we have 7 factorial here. Here I explained, as I just said, to say how did we get this 4 factorial and 9 factorial here, and also how do you get 3 factorial times 4 factorial times 7 factorial. In how many ways can the books be arranged if the books of the same subject are put in alternating positions? Then we'll have 3 factorial times 4 factorial times 5 factorial times 3 factorial. So meaning is the maths books together, history books together, literature books together, times the 3 groups, which is 103,680 arrangements, possible arrangements. So it means the group of maths books, the group of history books, the group of literature books, times the 3. Now we have 3 groups. Then that's why we have 3 factorials. It means these 3 groups can be arranged differently. Then I explained to say we have 1 group of maths books, 1 group of 4 history books, which can be arranged differently also, and 1 group of 5 literature books, and 3 groups. Passwords and codes. Letters and digits are used to create a password with 4 letters and 3 digits. How many passwords can be created? So because we know that we have 26 letters and 10 digits, which is digits from 0 to 9. First, you have to check whether the digits may be repeated or not. Here we say both letters and digits may be repeated. It means now when you choose the first letter of the password, you choose out of 26. When you choose the second letter, you still choose out of 26 because they are repeated. The third will be choose out of 26. The fourth you choose out of 26. So you stop here because you only have 4 letters. Now, then you have to choose 3 letters, 3 digits out of 9, out of 10. Then because repetition is allowed, remember the digits are 10, 0 to 9. Then first one, it will be you choose out of 10. Second one, you choose out of 10. Third one, you choose out of 10. That it means, yeah, you will possibly have 456 million 976,000 ways that can be formed, or passwords or the codes that can be formed out of this if letters and digits are repeated. I explained that letters and digits are used to create the password with 4 letters and 3 digits. How many? So we have total of 26 letters, which is A to Z. The total of digits, which is 0 to 10 digits, 0 to 9. And then as I explained, you're doing this because we repeat. The next one, letters and digits may not be repeated. So we still have 26 letters and 10 digits, but repetition is not allowed. When you choose the first letter, you choose out of 26. Second letter, you choose out of 25. Third letter, you choose out of 24. And then fourth letter, you choose out of 23. And then the digits also, you choose out of 10. The next one you choose out of 9. The next one you choose out of 8, because both the digits and letters are not repeated. The next one is if vowel and prime numbers are excluded. So vowels there are 5. Then it means now we'll use only 21 letters out of 26. Here we say also prime numbers are excluded out of the 10 digits. The prime numbers we talk about 2, 3, 5, and 7. It means that now we are left with 6 digits. But here we say letters are not repeated, but digits are repeated. Hence we have 21 because we are using 21 letters, 20, 19, and then 18 because letters are 21 and they are not repeated, but digits are repeated. So we have 6 digits when we exclude the prime numbers. Then we have 6 times 6 times 6. So it means when you choose the first digit of the code, you choose out of 6. Second digit you choose out of 6. The third digit you choose out of what? 6. Then you'll have possible 31,226,240 passwords or the codes that can be created out of these characters. Here is the explanation, as I said. Now, here, digits 0 to 9 are used to create 4-digit password under the following conditions. Each 4-digit password should be a number greater or equals to 5,000. It should be even number, but it means we are forming every password or code will have 4 digits. We are saying each 4-digit password should be a number which is greater or equals to 5,000, and it should be an even number. Now, for 4-digit number to be greater or equals to 5,000, it must begin with letter 5 to 9. It can be 5, it can be 6, 7, 8, or 9. There are 5. Hence, we have 5 here. These 5 represent the numbers that can possibly be at the beginning for each 4-digit password. For each 4-digit password to be greater or equal to 5,000. Otherwise, if first one is 4, that 4-digit password will not be greater or equals to 5,000. It can only be greater or equal to 5,000 if at the beginning we have number 5 to 9. Hence we have 5 here. Please don't think this 5 is this one. No, it's not this one. It's the possible number, the numbers that can possibly be at the beginning, so that can be at the beginning, so that each 4-digit password is a number greater or equals to 5,000. Now this 5, for an even number to be for any number to be even, it must end with even number. So it means it must end with the numbers 0, 2, 4, 6, and 8. So it means that the numbers that can possibly be at the end for this 4-digit password to be greater or equal to 5,000, it must end with one of the even numbers, which are 0, 2, 4, 6, and 8. Now, and then so it means this 5 represent the numbers that can possibly be at the beginning, which is 5, 6, 7, 8, and 9. The other 5 represent the number that can possibly be at the end for this 4-digit password to be an even number. So those 5 numbers are 0, 2, 4, 6, and 8. If it doesn't matter what is in the middle, as long as at the end we have 0, 2, 4, 6, and 8, the number will be an even number. And then 10 means the digit number 2 of the password can be any number. 10 means the digit number 3 of the password can still be any number. So because if you have 5, 7, 9, 0, it's still an even number, it still meet this condition. It will be greater or equals to 5,000. It means that the digit number 2 or 3 can be any number as long as you dealt with the first digit and last digit very well. And then remember here, repetition here is allowed. So it means 2,500 password can be created if in such a way that the 4-digit password is a number that is greater or equals to 5,000. So 5 means the numbers that can possibly be at the beginning. 5 means the numbers that can possibly be at the end. 10 means that the digit number 2 of the password can be any number from 0 to 9. The third digit of the password can be any number from 0 to 9. So the possible number of 2,500 passwords can be created. But now let's look at this one. If now digit may be repeated. Now to avoid repetition, so we know that the numbers that can be at the beginning cannot be at the end. So the numbers at the that should be at the beginning can be 5 up to 9. So 6 and 8 can be at the beginning, but should not be at the end. So hence, we're separated the even number that can be at the beginning and odd number that can be at the beginning. So meaning this 3 represent the odd numbers that can possibly be at the beginning, and then 2 represent the even numbers that can possibly be at the beginning, meaning this 3 represent is what? 5, 7, and 9. This 2 is 6 and 8, but both of them, these are the numbers that can be at the beginning. Now for the first, this first term, it simply means that if the first number is odd, if the first number is 5, 7, or 9, it means the numbers at the end can still be 5. It can be 0, it can be 2, it can be 4, it can be 6, it can be 8. But if here the first number is even, let's say the first number is 6, then now 6 cannot be at the end. So it means at the end it can only be 0, 2, 4, and 8. So that's why we have 4 here. It means if the first number is even number, either 6 or 8, it means the numbers that can possibly be at the end will be 1 less So if the first number here is 8, it means the even numbers that can be at the end will be 0, 2, 4, and 6, because we don't want repetition. But if the first number is 6, it means 6 cannot be at the end. We can have 0, 2, 4, and 8. That is why we say if the first number is one of the two even numbers, then at the end we can only have what? 4, one of the 4 even numbers. But if the first number is the odd number, like 5, 7, and 9, all the even numbers can possibly be at the end. That's why we have 5 here. So now if we dealt with the first number, we'll be left with the 9. Then you choose the number that can be at the end. Then we'll be left with 8. Now it means when you choose the second digit of the password or the code, then you'll be choosing out of 8. When you choose the third one, you'll be choosing out of 7. So it means that possibly you'll have 1,288 password that can be created. Meaning, don't forget that the answer is not a password. The answer is the possible number of passwords that can be created which will meet this condition. Here is also the possible number of passwords here when the digits may be repeated. Here is when the digits may not be repeated. Here I did the explanation why. As I said, this is how I explain the things to say why do you have this, then I explained. Passwords and codes again. Registration code is created in such a way that a code begins with 3 letters followed by 2 digits, two letters, then KG. Now, all letters excluding vowels. The first 3 letters of the code are from B to J. Let's look at this one. We say the first letters of the code, we said vowels are excluded. The first letter of the code will be letters from B to J, but remember vowels are excluded. Now it means it can be B, it can be C, it can be D, it can be F, it can be G, it can be H, it can be J, and the total there are 7. These 7 represent the possible number of letters that can be at the beginning of that registration code. So because we said the first letter of the code must be from B to J. Now, but we excluded the vowels, then it will be 7. Now, the second letter, then it will be 6, because now digits are not repeated. So remember letters, we say the first 3 letters must be from B to J. It means first 3 letters must be chosen from B to J, excluding the vowels, which are 7, and then repetition is not allowed. It means now when you choose the first letter of the code of the registration code, you choose out of 7. The second one, choose out of 6. The third one, you choose out of 5. So now you go on and say the 3 letters must be followed by 2 digits, and then remember only digits. We say 2 letters and then the digits 1 to 8. So I think 8, it is cut 8 here, 1 to 8. I think rectify that, 1 to 8. So that's why we say 8. It means when you choose out of 8, the first letter you choose out of the digit you choose out of 8, the second you choose out of 7, because repetition is not allowed. Now, here we say at the end, there's a kg. So we can't say 2 because now we are not saying at the end we have k and g, because now arrangement is 1 here, is kg, so it will just be 1. But if we say at the end we have k and g, we'll write 2 because it means kg or g or k, gk. So but we say kg, so it will just be 1 because those two will be fixed that way, they will not be changed. Now, it means because letters are not repeated, it means we excluded the 5 vowels. We excluded the 5 vowels. Also, we excluded the kg. So then it's 19. Then we excluded. We can just say we excluded kg. We can just say, let's say now we'll say let's now we say now we remove this kg because I see that I was supposed to subtract kg. Let's say now let's remove the kg on the statement. Let's remove the kg on the statement because now I don't want to change this. But if kg is part of the statement, here it will be 15, not 18. Why do I say 15? You'll exclude the 5 vowels, then we're left with 21. We exclude the kg, then it will be 19. Then we exclude the tray that should be at the beginning. The tray that should be at the beginning, then we'll have 16. Sorry, 16 instead of 18. But let's say now this kg, by removing it, we remove the kg, we'll say we remove the kg on the statement, and it means it will be you remove the 5 vowels, then also you will remove the 3 letters that should be at the beginning. Then when you choose the letters after the digits, then you'll be choosing out of 18. Then when you choose the second letter, will be choosing out of 17. I'm saying this kg is removed from this statement. So it means the registration code will have 3 letters, 2 digits, and then followed by 3 letters, followed by 2 digits, then followed by 2 letters. So remember, all letters, we exclude the vowels. And then we also we exclude the numbers. We only use numbers from 1 to 8. So we'll say, since this must start with the first 3 letters must be B to J, and we're excluding the vowels. From B to J, excluding the vowels, excluding E, there will be 7. Now, if there are 7, we'll say, how did you get 7? We say B, B, C, D, E, sorry, E excluded, B, C, D, F, G, H, and J. There are 7. So it means when you choose the first letter of the code, you'll be doing this out of 7. Because repetition is not allowed. When you choose second letter, you choose out of 6. The fourth you choose out of 5. So this represents the first letter of the code, the letters of the code. But here for numbers, for digits, you use 1 to 8. You choose 1. When you choose the first digit, you choose out of 8. Choosing the second, you choose out of what? 7, because digits are not repeated. Digits are not repeated. Even we can say the letters are also not repeated. So I think in the statement I'll have to add this. Both digits and letters are not repeated. Both digits and letters are not repeated. But if letters were repeated, they will say 7 times 7 times 7. But let's correct the statement here. Digits and letters are not repeated, and kg is removed from this. So kg is removed, means k and g can still be used somewhere. So then we'll say 7 vowels are removed. So it means letters will be 21, and also minus the letters that are at the beginning, then you will have 18. Then it means when you choose the letters after the digits here, you will choose out of 18. And then when you choose the second letter, it will be out of 17. So in the statement, let's remove kg, and also let's add that both digits and letters are not repeated. So because if they are repeated, it will be 777 here. So, but now if we say they are not repeated, so for us not to change our answer, so let's remove the kg, and also let's add that digits and letters may not be repeated. Work example 1. Here I just took this from past papers. I'll just quickly go through this. There are 5 chairs on the stage. 3 boys and 2 girls must go on stage. How many possible ways are there for them to sit? Obviously, there are 5 factorial, which is 120. How many possible ways are there for them to sit on stage if girls sit next to each other? If girls sit next to each other, so we are not saying at the beginning or the end, so it will be those 3 boys who are not sitting next to each other plus group of girls. Then we have 2 groups here. So we will have here, this 2 is for the 2 girls sitting next to each other. This 4 is the boys that are not grouped plus the group of girls. That is 4 factorial. Then that will be, this is for girls, this is for boys plus the group of girls, which is 4 factorial. Then the answer will be 48. Calculate the probability that the boys will sit next to each other with the girls at the 2. Calculate the probability that the boys will sit next to each other with the girls at the 2 ends. So now here we'll say 3 factorial. This 3 factorial, the boys will sit next to each other, and then the girls will sit next to each other. So here we can just say, I think in the statement I can just say, calculate the probability that the boys will sit next to each other at one end, and the girls sit with each other on the other end. So, but if I say girls sit next to each other, boys sit next to each other, it simply means that it will be 3 factorial times 2 because they sit next to each other, but they can be on both ends. But here, boys on one end, girls on one end. So the probability will be 3 factorial for boys. They can be different, and then times 2 divided by 5 factorial, which is the total. And let's not forget that for probability, every time when they say the probability, you follow all the method that I showed in the previous slides, but you divide by the total. But that total, we say the total, then you say the total, then you say factorial. So all the method that you followed in the previous slides. If they say number of outcomes, you follow those methods. But if they say probability, then you will divide by the total. So here their total is 5, then you say 5 factorial. Then the probability will be 1/10. If the boys sit at one end and the girls sit at one end, not at any end. But if they say the boys together, girls together, we'll say 3 factorial times 2 factorial, which is for girls, times 2 factorial is for two different. They can be on the left, boys can be on the left, girls on the right, or vice versa. But now, because we're saying at one end, boys at one end, girls at one end. So we can say just say on the left end and the right end. One end. We are not saying both can be, we say on one end and then the girls on one end. Then it will be 3 factorial times 2 factorial over 5 factorial. Some of the things were, as I'm saying, as I rectify as I go, because I was typing fast, I didn't get a chance to go through that. But wherever I said rectify, please rectify. The digits 3 to 9 are available to set a 4-digit code for your locker at school. How many different codes are possible if the digits may be repeated and the code must be an even number less than 6,000? So obviously, for this number to be less than 6,000, for this code to be an even number less than 6,000. So we'll look to say for number to be less than 6,000 with these values. So it means 5, 4, and 3 can be at the beginning, because you can't say 6 because if you say 6, we say if a number starts with a 6, it cannot be less than 6,000. It means the numbers that can possibly be at the beginning can be 5, 4, and 3, because we are using letters from 3. But if they were saying you are using all the digits, we'll say there will be 6, because we'll include 2, 1, and 0. But in this case, we said we use 3 to 9. Then it means the numbers that can possibly be at the beginning are 3, which is 5, 4, and 3. Numbers that can possibly be at the end. Remember, for number to be an even, it must end with an even number. So what are the even numbers in this case? We talk about 4, we talk about 6 and 8. That's why I have 3 here. This 3 represent the numbers that can possibly be at the end. But because repetition is allowed here, it means now digit number 2 can be any number from 3 to 9, which are 7. Digit number 2 and 3, they can be 7 and 7, because they can be 7. You can choose from 7, because when you choose number 2, you can choose any number from 3 to 9, they are 7. When you choose digit number 3 of the code, you can still choose any number from 3 to 9, which are 7, if we dealt with first one and the last one very well. Calculate the probability that the code will start with an odd number and be divisible by 5. So the digits may be repeated. Now, the digits 3 to 9 are available to set a 4-digit code for your locker at school. It's still the same question statement. So, but we say calculate the probability that the code will start with an odd number and be divisible by 5. The digits may not be repeated again. Oh, sorry. I made mistake here. Okay. In this case, the denominator will be 7 times 6 times 5 times 4, because now we talk about 4-digit password. It means the total will be which is 7 times 6 times 5. It will be 7 times 6 times 5 times 4. That's the total, because now we are talking about a 4-digit width. So let's not forget that here the denominator will be 7 times 6 times 5 times 4, because repetition is not allowed. So and then here let's explain the denominator. We say the code will start with an odd number. How many odd numbers do we have? We'll have uh, we'll have 3, and then we can have 5. Let's quickly do this. I want to take you this. Now, why do we say 3? Because the number must be less than, let's go back here. The number must be less than 6,000. It must start with numbers that can possibly be at the that can possibly be at the beginning. It can be 3. It can be 5, and then it can be 3. It can be 5. Let me just say, let's do the odd number, which is divisible by 5. I think here, with these conditions, I think here it was supposed to be 2. If you start with an odd number, if we still follow the same conditions, it was supposed to be 3 and 5. Here is supposed to be 2. These are the numbers that can possibly be at the beginning if we still follow the same, because this must be less or equals to 6,000, and then the numbers that can be odd numbers below 6 is 3 and 5. Then here must be 2. Then for number to be divisible by 5, it should end with 0 or 5, but here 0 is not included. Then it's 1. It means the only at the end we can only have 5 for this number to be divisible by 5. Then from there we'll be left with 5 numbers. Then to check the second one, you'll be choosing out of we'll be choosing out of 5 to choose the third digit. You'll be choosing out of 4, but here it will be 7 times 6 times 5 times 4 as the total. Then you get the answer. Now let's look at the answer and then rectify. Let me just get to my calculator and see. It means on the denominator we have 3. So to have 2. 2 means the numbers that can be at the beginning are odd numbers. If they are odd numbers, then it can only be 3 or 5. Say 2 multiplied by 5 multiplied by 4 multiplied by 1. 1 means that because 0 is not included, for any number to be divisible by 5, it must end with 5. The only number that can be at the end is 5. But if the 0 was included, we could have 2 here. But 0 is not there. 1 represents the number that can be at the end, and that number is 5. Now, meaning it will be 2 times 5 times 4 times 1, over 7 times 6 times 5 times 4. Then the answer will be 1 over 21, not 1 over 14. Because if we say the code will start with an odd number, the odd number that is less than 6, it can only be 5 and 3. And it can only be 5 and 3. And to get our total, because we talk about 6-digit password and 4-digit password, and use 7 digits, and repetition is not allowed, then on the denominator will say divided by 7 times 6 times 5 times 4. The answer will be 1 over 21. Please rectify that. So let me repeat this one. The answer will be 2 times 5 times 4 times 1 over 7 times 6 times 5 times 4, because we talk about 4-digit password. It means the total will be 7 times 6 times 5 times 4. Worked example 3. In Free State, license plates are designed with 3 letters of alphabet excluding vowels next to one another, and then any 3 digits from 0 to 9 next to one another. FS is constant at all Free State license plates. For example, KSF 987FS. Letters, digits may be repeated in the license plate. How many unique license plates will be available if letters and numbers are not repeated? Now, how many unique license numbers will be available if letters and numbers are not repeated? Let's look at this. Now, remember, we say vowels are excluded, but letters and digits are not repeated in this case. Now, then it means you are going to use choose out of 21 letters, and then when you choose the second letter of the plate, the registration plate, and then you choose out of 20, the third one you choose out of 19 because there's no repetition. Then 3 digits we choose out of 0 to 9. Remember, there are 10. Repetition is not allowed. You say times 10 times 9 times 8. Then the answer will be the possible number of license plates that can possibly be created by Free State government. Hence, determine the probability that the license plate will start with a 6 in keeping with the order above if repetition is not permitted. So now we say the license plate will start with 6 in keeping with the order. And before I forget, let's go back here. FS, you can't say times 2. Why? Because FS is at the end. But if we were saying it ends with F, letters F and S, then we'll say 2 because it will be 2 possible arrangements. It will be FS or SF. But here it's fixed. So you can just say times 1 because this one is a fixed. F and S are fixed and they are not changed. Hence, determine the probability that the license plate will start with a 6 in keeping with the order above if repetition is not permitted. We still have 21 times 20 times 19. Now here we say the digits will, if the digits start here, I'll say if the digits start with a 6, so it means first digit is 6. That's why you say 1 here. Because why do you say 1? Because now I think the statement I said here, I must say the license plate, the digits on the license plate, the digits start with a 6. So we are calculating the probability. Remember, by probability, you need to determine the totals. So now, if they start with a 6, the digits start with a 6. Like here is this, and then here the first number is a 6. So it means we say 1. Why? Because the only one number that can be at the beginning of the digits. Then from there, you can say times 9, because once you choose 6, then because repetition is not allowed, then it means when you choose the second digit, you'll be choosing out of 9. Choosing the third digit, you'll be choosing out of 8. So then you divide by the total. Remember, following the order, the total will be 21 times 20 times 19 times 10 times 9 times 8, because now order is when you use all the digits as the statement says. So then the answer will be 1 over 10. Here we determine the probability, or we did that. 1 out of 10. This is the question that was given in Gauteng prelim last year, when they say you have to choose a password from your new Facebook profile. The password must be in a format, double hash, double add, and then where hash is any digits from zeros, and zero is not included, and add is a vowel. You may repeat any digit, you may not repeat a vowel. As we said, digit may be repeated, but remember, we're excluding a zero. Digits are 10, but zero is excluded. We say 9 times 9 times 9. It means the first three digits you choose from 9, and then you say 9 times 9 because they are repeated. Now, the next two letters, you are only using 5 numbers which are vowels. Then you say 5 times 4. Why do you say 5? 5 times 4? Because letters are not repeated. Letters are not repeated. So remember, letters use only the vowels. It means when you choose the first vowel, you choose out of 5. The next one you choose out of 4. Then that's the answer of the possible number of passwords. This is the example that I just chose from Gauteng paper last year. It's not like they are going to give the same, but it's just a question of just applying what I emphasized in the previous slides. Our next question: towards the end of 2023, the KZN Traffic Department introduced a new number plate system for cars in the province. Each new plate consists of 2 letters of alphabet, followed by 2 digits, followed by 2 letters of alphabet, ending with ZN. Here I was supposed to say ending with ZN, not GP. And then one example is such a number like HG56KT, let's say ZN, but it doesn't matter because this will be fixed. It will be ZN. All 26 letters of alphabet excluding Q and 5 vowels may be used. Any two digits from 0 to 9 may be used. How many different plays can be made if letters and digits may be repeated? Since we don't use the vowels and Q, so it means we subtracted 6 letters out of 26, so we're left with 20. So we say 20 times 20 if you want to choose the first 2 letters. And then say it means when you choose the first one, you choose out of 20. When you choose the second one, you choose out of 20 because you repeat. And then when you choose the digits, you choose out of 10 because all the 9 can be used, and then repetition is allowed. Then they'll follow the second. Here it would either be letters. Remember, repetition is allowed. We still choose out of 20. And then the second one choose out of 20. GP or ZN. It is supposed to be ZN. ZN, nothing is happening because it's fixed. We're not saying they cannot be arranged. So it will just be 1 because they'll be fixed there. How many different number plates can be made if letters and digits may not be repeated? Still the same thing. Choose 20, then it's 19 because we don't repeat. The digits are 10. When you choose the first digits, you choose out of 10, and then you choose out of 9. Now, remember, you chose the first 2 here. Now, when you choose the last 2 letters, you'll be choosing out of 18 because the first two are at the beginning. Then choose out of 18, then you choose the last one, choose out of 17. Then the answer here will be the possible number of number plates. If letters and digits may not be repeated, what is the probability that number plates of this form will start with letters B and C in any order? That's why we say in any order. Remember, they're not saying starting with BC. They're starting with BC with any order. So it can be BC or CB. That's why we have two, because we have two possibilities that you can arrange the letters at the beginning is two. And then remember, we say letters may not be repeated. That when you choose the digits, you can choose 10 out of 10, then out of 9, because you choose 2 and then they are not repeated. Then when you choose remember B and C are excluded here. When you choose the letters here, you'll be choosing out of 18. 18, then you're going to choose the last letter of will be out of 17. But remember, GP is fixed. Then you divide it by the total. The total, we calculated it here. When the digits are not repeated, using all the letters and all the digits that the statements say you use, then you divide it by the total. The answer will be 1 out of 19. Next example, a company generates a 4-character coding using the 26 letters of alphabet, the 10 digits from 0 to 9. Determine how many different codes can be formed if letters and digits may be repeated. If they may be repeated. So it means when you choose the letter, you'll be choosing out of 26. When you choose the first digit, you'll be choosing out of 20. The second letter will be choosing out of 26. The last digit will be choosing out of 10 because they are repeated. Now, second question, determine how many different codes can be formed if D, F, I, Q, U, V may not be used. It means they will be subtracted. It means we'll subtract this, how many letters? To 6 letters. Then it means we know that we're left with 19 letters. The code may not start with W or a Z. Now, it may not start with W and Z, but you can still use W and Z in other, you can somewhere, but it may not start with W or Z. Letters or digits may not be repeated, and the code ends with odd digit. Let's start with this one. Remember now, we are excluding D, F, I, Q, U, and V. So, and then also the code may not start with W and Z. It means at the beginning, you can choose out of 18. You can choose out of 18. It means the first code, the first letter can be chosen out of 18 because we exclude the 7 letters here, and W and Z cannot be at the beginning. Now, the digit, the statement says the code ends with an odd digit. So it means now the odd numbers are 5. Now it means we choose odd number out of 1 out of 5 to be at the end so that we avoid repetition. So it means now when you choose the first digit here, you'll choose out of 9 because there are 10 in total. You choose out of 9 because 1 must be at the end, meaning that if 1 is at the end, then 1 cannot be here. If 3 is at the end, 3 cannot be here. If 5 is at the end, it cannot be here. If 7 is at the end, it cannot be here. But you have 5 choices of these odd numbers. So it means the first digit can be any number, but not the one that is at the end. So that is why it will be 9 here. So now, we didn't say W and Z cannot be used. We said cannot be used at the beginning. So it means W and Z can still be used as the second, as the digit, so as the letter here. So it means letters used in total, there must be 20, because we'll only exclude D, F, I, Q, V, U, and V. So there are 20. But now, if now one of the letters is W, or so remember, if one of the letters is used here, remember the total letters that can be used here, there are 20. But if one of them is at the beginning, then it cannot be here. Remember here we use 18 because we said at the beginning we cannot have W and Z. But here we can use them. Remember, letters that can be used here are 20. We only exclude the 6 here. But now, here they can't be 20. Why not 20? Because 1 has been used here. If now, for instance, if T is used here, then T cannot be used here. Out of 20, then we'll have 19 here. Then 5 is the possible number of digits that can be at the end. Here we're referring to the odd numbers. Then the answer will be the total number of the codes. Example 6, the company wishes to increase the number of 4-character codes formed in question 1.2 by allowing the letters, we still the same, by allowing the to be used. We're still having this, the same thing. Calculate the percentage increase of different codes. We are still in the same question, but now this is the sub-question. Calculate the percentage increase in the number of different codes that can now be formed. First, we are going to say now if we are using these letters now, but excluding this one. Remember, they cannot be W and Z cannot be used at the end, but now you can use this 6. Then it means at the beginning we can have what, 24. You can use 24 letters because now W, Z cannot be used, but now D, F, I, Q, U, V can be used. Then it means when you choose the first one, you can choose out of 24. We're still following the same method. If the odd number is at the end, it cannot be here. But here, W and Z can be used out of 26 letters. But now, if 1 is used at the beginning, it cannot be here because letters are repeated. Hence, we have 25 here, not 26, even if you use all of them, because 1 will be at the beginning and repetition is not allowed. Now, when you calculate the percentage, it will be this one minus the answer in the previous one divided by the total. Remember, the total will be when we follow the procedure that we followed now in the previous one. We said 27,000 minus 15,390 divided by the total. This will be the percentage increase. I close this by the words of encouragement, as I always do. Character cannot be developed in ease and quiet. Only through experience of trial and suffering can the soul be strengthened, vision cleared, ambition inspired, and success achieved. This These are the words of Helen Keller. Thank you so much for attending. Keep on attending. Please subscribe. Then until we meet again in the next lesson.